Hey, let's take a look at page 3 of your assignment. On the first one, we've got this rhombus. Remember, all the sides are equal in a rhombus, and its perimeter is 20, so I want to find the length of one side. So all I do is I take 20 divided by the 4 sides, and each length is 5. Now I want to find the length of the other diagonal, so what I'm going to do is I'm going to draw a rhombus here. I know each side is 5. I know when I draw in the two diagonals, they don't have to be equal, but they do bisect each other. So I know if one length is 4, that means, notice that we've got a Pythagorean triple here. The most common Pythagorean triple, 3, 4, 5. So I know the length of my other diagonal, I'll call D2. Well, that's going to be 6. In 27, we've got this triangle here, and I want you to find x. And the first thing I notice, I can't find x straight because I don't know b to f. But I do see I've got this right triangle here. So let's go ahead and do that one first. So on that one, I know my hypotenuse is 13. And I know one of the legs is 2.7. And then I'm going to solve for f to c. Well, notice when I do 13 squared, well, that's 169, isn't it? So 169 equals 2.7 squared is 7.29 plus fc squared. Well, I subtract 7.29 from both sides. Fc squared is going to be, if I could write, there we go. So fc squared is the square root of 161.71. Got to help ahead of myself there. So fc is the square root of 161.71. That doesn't help me directly. I'll say the square root of 161.71. That doesn't help me directly to find x. But let's look around. Here's another right triangle I can find. BDA, or ABD, is a right triangle. So I'm going to say, on that one, I know my hypotenuse is 11.6. So 11.6 squared equals BD squared plus 7.5 squared. And now we're going to simplify and solve that one. So 11.6 squared is 134.56. Equals BD squared plus 7.5 squared is 56.25. So let's subtract 56.25 from both sides. And then I'm kind of going to run out of room here, aren't I? But then I'll get 78.31 equals BD squared. Or BD is the square root of 78.31. Then that forms another right triangle. Notice BDC is my other right triangle. I already know part of BC is the square root of 161.71, but I'm going to use that part to find B to C. So I'm going to say, oh, my hypotenuse, whoops, I want a pen there. So my hypotenuse is going to be BC squared equals 15 squared plus the square root of 78.31. So in other words, BC squared equals 225 plus 78.31. So BC squared is going to be 303.31. Or B to C is going to be the square root of 303.31. So to find B to F now, I'm just going to take BC minus FC. Or BF is going to be the square root of 303.31 minus the square root of 161.71. Well, if we do that with our calculator, so I'm going to take the square root of 303.31 minus the square root of 161.71. And I'll get about 4.70. And then finally, we can solve for x now. X is my hypotenuse. Well, maybe I should write this in. So this is 4.7. Kind of short on room here, aren't we? Should have left you more room here. So x squared equals 4.7 squared plus 2.7 squared. So if I take 4.7 squared plus 2.7 squared, let's go ahead and do that on our calculator. I get about 29.37. Take the square root of both sides. And then I think I'll round this one to the nearest tenth, because that's what they're asking for. And we get about 5.4. That is one of your standards used in Pythagorean theorem multiple times to solve a problem. And you will have a question like that on your test. Now in question 28, we want to know if I've got two right triangles with the same hypotenuse. Well, are they going to have the same area? Well, sometimes they will, but not always. So I would say that's going to be false. Because if I think here, if I've got the same hypotenuse, I could still have triangles that aren't congruent, because no one says just because it's a right triangle and you've got one leg the same or one hypotenuse the same, your legs could be different. And obviously they're going to be irrational numbers, but that would work. So for example, if I think here I'd have like the square root of 6 and the square root of 2, the square root of 4, and the square root of 3. Remember, the square root of 4 is actually 2. But I can definitely see I would not have the same area, so that would be false.